This is the answer key for Prealgebra Chapter 6 practice test. First question is, why do you get a different answer when you calculate the number of ways 4 of 17 eighth graders can sit in a row of 4 chairs as compared to the number of ways 4 of 17 eighth graders can be picked to serve on a committee? Sitting in the chairs is a permutation, so it would be you have 17 and you're picking 4 of them. That would equal 57,120. And you don't have to say what these answers are. You just have to say one's a permutation, one's a combination. But when you do combination, you have to divide that 57,120 by the product of 4, 3, and 2. And the result would be 2,380. So order matters when you're sitting in chairs, but order doesn't matter when you're picking the committee. So one's a permutation and one's a combination. Number 2, you roll a number cube and toss a coin, either one right after the other or at the same time. Are the outcomes of the 2 events independent, which means the outcome of one doesn't affect the outcome of the other? Are they dependent, where one outcome does affect the other? Are they mutually exclusive, where they can't happen at the same time? You can rule out mutually exclusive pretty easily because you can roll a number cube and toss a coin at the same time. They're not dependent because whatever happens on the number cube has no effect on what happens on the coin toss, so that leaves independent, and it fits the definition. The outcome of one doesn't affect the outcome of the other. So those are independent events. I'll show you 2 ways to do a permutation of 8 things taken 3 at a time. The formula would say that this is equal to 8 factorial over 8 minus 3 factorial. So this would be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And 8 minus 3 is 5, so it's over 5 times 4 times 3 times 2 times 1. This would all cancel. So you would have 56. 8 times 7 is 56. And then times 6 would give you 336. So this would equal 336. Another way to do this, let me speed this up a little bit, would be to just say I've got 3 slots to fill. And 8 things can go in the first slot, then 7, and then 6. And again, that gives you 336. Or you could punch it on your calculator and get 336. Number 4 is related to number 3. Instead of a permutation, we're going to find a combination of 8 things 3 at a time. And that would equal, the formula for that would be to take the permutation. I'm going to start that over again. Of 8 things 3 at a time, and then divide it by 3 factorial, which is this number factorial. So we remember this was 336 divided by 3 times 2 times 1, which is 6. And when you divide 336 by 6, you get 56. Put it on your calculator, you get the same answer. So I just took a little shortcut. There's no need to figure out what this was again, because we already did that in number 3. 5 factorial equals 5 times 4 times 3 times 2 times 1. And when you do the multiplication, you get 120. Number 6, how many different 2-digit numbers can be made from the following number tiles? 1, 2, 3, 4, and 5. So we're trying to calculate a permutation because order matters here. We have 5 things and we're taking 2 at a time. This is a quick way to do this. It's how many can you pick for the first digit? That would be 5. How many for the second digit? 4. So the total would be 120. Or if you follow the formula, it would be, move this up a little bit, 5 times 4 times 3 times 2 times 1 divided by 5 minus 2, which factorial 3 times 2 times 1. That cancels, and then you're going to get the 5 times 4, which is 20. Number 7, all 72 middle school students are entered in a drawing. 5 music CDs, 3 computer games, and a graphing calculator will be given away. To the nearest whole percent, what's the probability of winning a prize or a CD? Well, there are 5 CDs, 3 computer games, and a graphing calculator. So that makes 9 prizes. And your probability of winning one of them, if there's 72 students, probably of any one student winning one of those would be 9 out of 72, which is 1/8. And 1/8 is 12.5%. So to the nearest whole percent, you would say 13%. The probability of winning a CD is 5 out of 72, because there's 5 CDs. And when you do that division, you get about 7%, 6.9%, or 7% to the nearest whole percent. When you toss 4 pennies, what's the probability that they all land on heads? These are 4 independent events. The probability of getting heads on any one of those events is a half, and you're going to do it 4 times. So you have to multiply 1/2 4 times, and that result is 1/16. So the probability of getting 4 in a row of heads is 1 out of 16. Number 9, 5 cards are numbered 1 through 5. They're shuffled and placed face down. What's the probability of drawing 2 odd numbers with the first 2 draws without replacing the first card that you draw? So if we do a little diagram of this, we'd have a 1, a 2, 3, a 4, and a 5. So we're going to draw 2 cards. There's 3 odd numbers. There's the 1, the 3, and the 5. The probability of getting an odd number on the first draw is 3 out of 5. And let's say it was a 5, so it's no longer there. It could be any, the 1 or the 3, it doesn't really matter. But there's 2 odd numbers left, and there's only 4 cards left. So these are dependent events, and the formula says just multiply their separate probabilities together to get the probability of them occurring one after the other. So we could reduce before we multiply, or just not. But the 2/4 is the same as a half. Say we didn't reduce, we'd get 6/20. Then we have to divide by 2 and get 3 out of 10. So the probability of getting 2 odd numbers would be 3 out of 10. Number 10, there's 4 of 10 8th graders are randomly chosen to give a speech in the chapel. What's the probability that you're chosen on the second draw? Well, if you're picked on the second draw, you can't be picked on the first draw. So the probability of not getting picked on the first draw is 9 out of 10. And then there are 9 names left in, and you're one of them. It's 1 out of 9 on the second draw. So these are 2 dependent events. So 9 we can reduce here before we multiply. And you get 1 out of 10, which is sort of the intuitive answer to this question anyway. The probability that you're picked on any given draw is 1 out of 10. You could be 1 out of 10 chances of getting picked on the 4th draw, 1 out of 10 that you get picked on the 3rd draw, etc. But this is sort of the math that explains why that works. What are the odds that you're chosen on the second draw? If you know the probability that you're chosen on the second draw, you can use that number. So the probability of being picked on the second draw was 1 out of 10. The odds of getting picked on the second draw, well, this is a comparison of the number of ways that can happen. One way out of the total number of ways, 10, odds compare the number of ways that can happen to the number of ways that it can't happen. So there would be 9 ways that you're not picked on the second draw. So the odds are 1 to 9. How many ways can 4 people be chosen? That would be a combination, picking 4 things out of 10. So once you identify that, you can punch it in on your calculator. You can apply the formula, which would be 10 times 9 times 8 times 7 divided by 4 times 3 times 2 times 1. And we can let the canceling begin here. A 4 and a 2 is an 8. And 3 goes into 9 3 times. 3 times 10 gives us 30. And 30 times 7 gives us the answer, which is 210. 210 ways that 4 people can be chosen. Letter D, what's the probability that you and your 3 best 8th grade friends are chosen? So we're picking 4 people, you and 3 friends. It's important to read this question carefully so you see you're picking 4 people. And order doesn't matter. So we've done a lot of the work to answer this question. It's a combination of picking from 10 things taken 4 at a time. There were 210 ways to do that, and only one of those 210 ways is you and your 3 best friends. So the probability is 1 out of 210. So you have to get question C right in order to get question D correct. Number 11, have a burger your way. Choose from ketchup and mustard. How many ways can you have the burger? A sample space is probably the best way to answer this question, but it's a little tricky because you have to keep in mind that you can have nothing. So one way is none. or no condiments. Nothing. I'll put nothing. You can have them individually. You can have just ketchup. You can have just mustard. Or you can have both. And those are the 4 ways that you can have that burger. So the answer is 4. Number 12, you roll a number cube. If you roll a 5 and then another 5, you win a prize. What's the probability that you'll win the prize? There are 6 outcomes when you roll a number cube, so the probability that you get a 5 on a single roll is 1 out of 6. The outcome of the second roll has nothing to do with the outcome of the first roll, so these are independent events, and you multiply them together to find the probability they happen back to back. So the probability of winning is 1 out of 36. Number 13, you buy a gift for your mom, you want to have it wrapped. There's 5 colors of wrapping paper, 6 ribbon colors, and 3 sizes of boxes. How many options are there for wrapping the gifts? This is an application of the fundamental counting principle. So you're going to there's 2 categories, and there's choices in each category. So you have 5 kinds of wrapping paper, 6 kinds of ribbons, and 3 sizes of boxes. So that when you multiply them together, you get 90 different outcomes. Number 14, when calculating the probability of 2 independent events, what do you do to find their separate probabilities? It's either add, subtract, multiply, or divide. This is a question like number 12. The 2 rolls of the number cube are independent events, and to get that answer we multiplied, so this is multiply. 15, when calculating the probability of 2 mutually exclusive events, what operation do you use with their separate probabilities? Mutually exclusive events cannot happen at the same time. It's like when I toss a coin, I'd ask, what's the probability of getting heads or tails? That's 2 mutually exclusive events because they can't happen together. When you calculate these probabilities, you find the separate probabilities, like the probability of getting heads is 1/2. Probability of tails is 1/2. Then I add them to find the probability of getting heads or tails. And since that's the only thing that can happen, I am going to get one or the other, so the probability is 1. Another example, if I'm rolling a number cube and I went into the probability of getting an odd number, I would say the probability of getting a 1 is 1/6, a 3 is 1 out of 6, and a 5 is 1 out of 6. So when you add that, you get 3/6 or 1/2. So this is add. They're separate probabilities. And keep in mind, mutually exclusive events, when their total can never be more than 1, so if there's something happening and you consider all the different outcomes, when you add them together, you should get 1.